Hello, my name is Ki-Joune. I'm working at Busan National University in South Korea. Today, I will give a very short presentation on indoor spatial data model defined in CityGML version 2. First of all, let me briefly introduce OGC, which stands for Open Geospatial Consortium. In this structure, there are many geospatial standards, including CityGML, that we will talk about. CityGML, it is an application schema defined on the top of GML, a geographic markup language. And the GML is also an application of XML. The basic data model defined in GML, it comes from ISO standard defined by ISO TC211, like ISO 19107 for spatial data model, or 19109 for application schema, and so on. And on the top of GML, you can also define application domain extension. For example, the application domain extension for noise simulation or disaster management, and so on. The basic goal of CityGML is to provide a 3D city model. That means a 3D topographic map model or the feature model for 3D city. So this model is provided in XML document. So in CityGML, they provide XML schema. First of all, the basic concept of CityGML is so-called level of detail. It includes 5 different levels of detail from LoD0, which defines the digital terrain model. And LoD1, it is very simplified city model using a box model. As you see here, a 3D city model of LoD1, it is a set of boxes where each box represents each building. And LoD2 is a little bit more detailed city model like this one, which include texture on the wall and the roof style. So this is LoD2, and LoD3 is the most detailed city model like this one, where we can describe very detailed of the architectural component, like the wall or the window or door or the texture of the wall, and so on. So this is the most detailed description of city model. And LoD4, it is only for indoor space, while LoD0, 1, 2, 3, it defines the outdoor space. So we will talk about LoD4 for indoor spatial data model. So basically, CityGML defines CityGML core module, which provides a geometry module and some other very basic module. And using a CityGML core module, we can define several symmetric models like relief. Relief means the surface modeling, or 3D object group and building, bridge, tunnel, and so on. So here, the LoD4 or indoor spatial data model is included in the building model. So we will give a look at the building model. So basically, the building model is composed of several feature types. The central feature type is a building. So a building is composed of several rooms here, and the room is surrounded by boundary surfaces. And the boundary surface, we can attach an opening like a window or door. And in a building, in a room, there are many building furniture like a table or chairs or a library and so on. And also in a room, we can place indoor building installation like a stair or some other building component placed in a room or a building. So this is a interior building installation, and likewise we can define a building installation which is installed outside of the building, like a veranda or outside the stair and so on. So these are very basic feature type defined in a building model of CityGML. So we may define such features in an indoor space. For boundary surface, which is a little bit complicated in CityGML, we defined several different types of surface, like a floor surface and the ceiling surface, and interior wall surface. Interior wall surface, that means the vertical wall surface, and some other different surface like ground surface and roof surface and wall surface, closed surface. Closed surface is a kind of a virtual surface. For example, if you want to make a virtual wall to separate one single room into two sub area, then you can use the concept of a closed surface and outer floor surface and outer ceiling surface and so on. These are the types of boundary surface in an LoD4. And the geometric type, the geometric type of CityGML for LoD4 is a solid and multi-surface. The feature type in indoor space which can have a geometry is only room and boundary surface and opening. These three feature types can have the geometry. So first, the room, it can be defined as a solid. Solid means a closed geometry. And multi-surface, that means a set of surface. So you can define a room, the geometry of a room, either by solid or a multi-surface. There are two different approaches. And for boundary surface, you can define the geometry using the multi-surface. And very similarly, for opening, you can define it using multi-surface as well. So because window and door are the subclass of opening, so the geometry of window and doors are multi-surface. These are the geometry. So using this concept, you can define the geometry. And for the attribute, there are several attributes for each feature type, but I will not explain it. But in this full diagram of UML, you may see the predefined the attribute for each feature type. For example, for abstract class, you have several attributes, and for room, you have attribute class, function, and usage. Now, of course, if you need, you may add some other attribute type for your application. This is a very brief sketch of CityGML indoor spatial data model. And in summary, this slide shows each feature type with this example. So opening means a door connecting outdoor space and indoor space, or connecting two rooms. And the floor surface, and interior wall surface and ceiling surface, or the outer wall surface, roof, exterior shell, and so on. So these are some examples of the feature type defined in LoD4. So these are the basic the concept. Okay. Thank you.